In this video, we're going to take a second look at the cars in the Canary scenario that we did the other day in class. So you have two cars and they are 360 kilometers apart and they're going to drive towards each other. One car is going 80 kilometers per hour and the other's going 100 kilometers per hour. And probably the first thing that you notice is that we're dealing with kilometers here, which are a metric unit, not miles. At the same time, the Canary is going to fly back and forth between the two cars, and the Canary is going to travel at 120 kilometers per hour, and you are expected or asked to find how far that bird will have flown when the cars meet. So let's take a look at what we are given and what we need to find. So go ahead and label a column given and another column find. And then let's take a look at what we know. So two cars are 360 kilometers apart. That's a distance. So D equals 360 km. And it looks like they gave us the velocity of both of the cars. So I'm going to label those V sub C1 and V sub C2 just to distinguish between them. So C1 is going to be 80 kilometers per hour. And C2 is 100 kilometers per hour. And the fact that they're using kilometers in this problem shouldn't bother you. It's not going to change the overall strategy that we use. It's going to be very similar, in fact, identical to what we did in class, okay? So let's see, do we have any other information? Oh, yes, they gave us also the velocity of the Canary. I'm going to use V sub B for bird, so I don't confuse that with the C's for car. And the Canary is traveling at 120 kilometers per hour. Okay, so what are we being asked to find? It looks like they're asking us to find how far the bird has flown. So how far, that would be a distance. So we're trying to find distance. And it would be helpful to know what the formula for distance is. And so let's take a quick review, or let's do a quick review of the relationship between distance, velocity, and time. So if you recall from your physics class or from our discussion, distance is rate times time, and in this case we're referring to the rate as the velocity, so v times t. And that means if we wanted to find the velocity, we would just divide both sides by t, so velocity is distance divided by time. And of course, to find time, we would just divide both sides by velocity, so time is distance over velocity. So that means that in order to find the distance of the bird, let me put a B there again, we are going to need to know the velocity of the bird and the amount of time that that bird spends flying. So we can look at our givens to see if we have either of those pieces of information, and we do in fact have the velocity. So I'm going to rewrite this one more time as D equals velocity. I'm going to replace that with 120 kilometers per hour. And then I'm going to put a multiplication sign, and I know that ultimately I'm going to have to multiply that by the time that the bird spends in the air to calculate the distance. Now, since we don't know the time, and we really don't have a direct way of finding it using the given information in terms of the bird, we're going to have to look at what's going on with the two cars. So I'm going to choose a different color, choose black, and let's take a look at what's happening with the cars, or what we know about them. So the cars, we have the velocity of both of the cars, and we also know how far apart they are. So we have the distance in a sense. What we need to do is figure out how long it's going to take those two cars to meet up, because that's the same amount of time that the bird is going to be in the air. So if I can find the time for the cars, I can find the time for the bird. So I'm going to remind myself of how you calculate time. Time is distance divided by velocity. And I know the distance flat out. Those two cars, they told me, are 360 kilometers apart. So I can go ahead and fill that in on the top. And then the question becomes, what do I use for the velocity? Well, you'll notice that the velocities are different for the two cars. So what do I do about that? Well, I have to think about the fact that these cars are driving towards each other. And one of the cars is going 80 kilometers an hour and the other one's going 100 kilometers an hour. But they're driving towards each other, which means for every hour that passes, they get 180 kilometers closer to each other. Say one's going east, one's going west. So one goes 80 kilometers east, the other one goes 100 kilometers west. They're now 180 kilometers closer than they were at the beginning of that hour. So that means that I can combine the two velocities to use for my time calculation. So I'm going to use 180 kilometers per hour for my velocity. And then it becomes pretty simple. All I have to do is divide 360 by 180, and actually I can cancel the zeros and just say what's 36 divided by 18, and that is 2. This is a time, so the units better come out in hours, and they do. But very quickly, let me show you why that is so. On the top for the units, let's take a look real quick at how those units work out. So for the units, on the top, the 360, you have kilometers. And on the bottom, and we'll put that over 1 since it's a single unit, on the bottom you have a double unit, but you're dividing there. And what you need to remember, back from your elementary school days, is that dividing by a fraction, even if it's units and not numbers, dividing by a fraction is the same as multiplying by the reciprocal. So really we're multiplying by hours over kilometers if we invert that, and we see that the kilometers cancel and we're left in just hours. So that time of 2 hours looks good. So now that I have that time, that isn't just the time for the cars, remember that's the time for the bird also. So now I can come over to where I was doing my distance calculation for the Canary, and I can say 120 kilometers per hour. And I can now multiply that by a time of 2 hours. And I'll go ahead and put that over 1. And the hours are going to cancel. And I can see that the only unit left is kilometers. And that's what I want because I'm trying to find a distance. And I know that if I double 120, I get 240. And of course, that's kilometers. And so that is my final answer. In that time frame that it takes for the two cars to meet up, the Canary will have traveled 240 kilometers. So this should help you with the question that's going to be on the test next week. And good luck. Email me if you have any questions.